This question is called moments of normal distribution, and it says if x follows standard normal distribution of x n 0 1, what is the expectation of x to the power of n for n equals 1, 2, 3, and 4? So, firstly, you have to know that the expectation of x to the power of n is equal to the moment generating function of said distribution to the power of, or taking the nth derivative, so the nth derivative of the moment generating function, and you plug in 0. Now, what is a moment generating function? It's some function, or m of t usually, that generates you moments of a distribution. A moment is pretty much kind of like the components of the distribution. So the first moment will tell you the mean, right? The second one will tell you the variance. The third one will tell you the skew. Fourth will tell you like how. I forgot the fourth one to tell you, but pretty much the distribution is comprised of all of its moments, right? So and each derivative of these moments is the expectation of the random variable raised to that derivative's power, or the power is equal to the derivative we're taking. So we have to find said moment generating function, and how we do that is we take the expectation of this distribution for e to the tx, and if you know how to find expectation for some function of a distribution, for example, the expectation of some u of x, right? That is going to be the integral from negative infinity to infinity of said function times the probability density function of the distribution. So the PDF in this case. So I'm going to write the general. That's a probability density function, sorry. And we have that function right here. Usually it's going to be memorized or on a cheat sheet, but I wrote it down here just so we know in advance. And so we're going to plug on our steps here now. So we want the expectation of e to the tx to get this MGF, or moment generating function. And that's going to equal the integral from negative infinity to infinity of e to the tx times 1 over 2 square root of 2 pi e to the negative x squared over 2. Now, I'm sorry if you came here to watch like the integration step, but I'm just not going to do it because it'll just take too long. But pretty much when you get the integration, you complete it, you're going to get e to the t squared over 2. And that is our moment generating function. And so we have to take this, so that's our m of x, or m of t, equals that. And we're going to have to integrate this 4 times. So we want m prime of t, we want m double prime of t, m triple prime of t, and m, I guess, 4. So 4 quadruple prime of t. The first derivative is going to be t e to the t squared over 2. The second one's going to be e to the t squared over 2, right? Product rule, plus t squared, right? Yeah, t squared e to the t squared over 2. Make sure. Okay, yeah. The third derivative is going to be t e to the t squared over 2 plus 2t e to the t squared over 2 plus t cubed e to the t squared over 2, and these combine into 3t. Let me make sure the last part. Yeah, okay. And the fourth derivative is going to be 3e to the oops, what is this? T squared over 2, 3 e to the t squared over 2 plus 3t squared e to the t squared over 2 plus 3t squared e to the t squared over 2 plus t to the power of 4 of e to the t squared over 2. Okay, now for all of these, we plug in 0. Right, so we're going to plug in 0. We're going to get 0 here. We're going to get 1 here. We're going to get 0 here. And we're going to get 3 here. So the four moments, so the answers for e to the x squared, e of x cubed, and e of x to the power of 4, we're going to got 0, 1, 0, 3. And those are our answers.